Welcome to the first module of Amazon Alexa and Makers Academy's short course on building Alexa skills using Ruby. Amazon's Alexa Skills Kit allows developers to extend existing applications with deep voice integration and to construct entirely new applications that leverage the cutting edge in voice control technology. During this course, we'll cover all the terminology and techniques required to get fully functional skills pushed live to owners of Alexa-enabled devices all around the world. We'll be using Ruby. So what's in this module? This module contains a basic introduction to scaffolding a skill and interacting with Alexa. In it, we'll introduce intent schemas, utterances, the Alexa communication paradigm, tunneling a local application using ngrok over HTTPS, connecting Alexa to a local development environment, Alexa-style JSON requests and responses. During this module, readers will construct a simple skill called Hello World. While building this skill, readers come to understand how the above concepts work and play together. This module will use Sinatra and Ruby's JSON library. Okay, let's get started. So there are going to be three parts to this process. The first is to set up the voice user interface on Amazon. The second is going to be to set up the back end. We're going to have a local tunnel development environment using ngrok. And the third is to link those two things together, to link the voice user interface together with our local endpoint. So let's go set up the skill on Amazon. The first thing you'll need to do is to sign up to the Amazon Alexa Developers Program. I've already done that here, and I've jumped to the Alexa pane in the developer dashboard. So let's get started by using the Alexa Skills Kit and clicking Get Started on the Alexa Skills Kit. Now we're going to add a new skill. We're going to use the custom interaction model for this because we're going to be building our own model from scratch. I'll leave it to the listener to read any of these further ones in more detail. Let's set up the app. We're going to start with language. I'm in the UK, so I'm going to use English UK, but there are very few functional differences between the two as it stands at current. We'll give this application a name, simply going to be Hello World, and an invocation name. So this is the name that customers use to activate the skill. So it'll start usually with Alexa ask and then the name of your program. So I'm going to go with Hello World as well. In terms of global fields in here, we're not going to be using any audio player directives or any video or rendering any specific templates. We just want Alexa to respond Hello World to our skill. Okay, let's save that up, and you can see here that our skill has been initialized correctly. This little green tick will give you that. Okay, let's jump into the interaction model itself, and we can start looking at some of the more detailed aspects of using Amazon Alexa. Now we have a new skill, we need to construct an intent schema. The intent schema is a JSON object that lists all the possible requests Amazon can make to your application. To do so, we're going to first build a minimal intent schema with a single property in here, intents. This intents object is an array, and inside it we're going to have a single intent. This intent needs to have a key of intent and a value of whatever we will call the intent name. So intents are like the various actions that your skill can take. As you can see, this minimal intent schema is a JSON object. We have a single property intents, and each action inside here, each intent, is another JSON object with a single property intent. And the intent property gives the name of the intent. So now that we have the intent schema, let's make utterances. Utterances map intents to phrases spoken by the user. And they're of the form, in here, they're of the form intent name utterance. So in our case, we have only one intent. That's hello world. So I'm going to swap out the intent name here to hello world. And we'd like the user to say the following. Alexa, ask hello world to say hello world. So our utterances are everything after our invocation phrase, and that is just say hello world. So the combination of this will allow the user to say, Alexa, ask hello world, which is the name of our application, to say hello world. And when the Amazon Voice Service receives this, it will map it to the hello world intent, which will be sent onto your application. So we're now done setting up our skill on Amazon Alexa's developer portal. Let's save that up. So our second step is to set up our local Ruby application ready to receive encrypted requests from Amazon servers. So that is HTTP requests over SSL, or as they're more commonly known, HTTPS requests. We'll walk through setting up a Ruby server using Sinatra, a simple Ruby server development framework. We're going to run it locally, and we're going to make sure that it's capable of receiving HTTPS requests from the internet through a tunnel. There are some alternative routes you could take to this. You could set up a remote development server using Heroku with Heroku SSL, or you could use Amazon Elastic Beanstalk with a self-signed SSL certificate, or any other method you can think of. And if you go to the corresponding blog post for this video, you'll find links on how to do all of those things. For us though, we're going to use ngrok to tunnel to a local development server. So, let's set up our Sinatra application with ngrok. The first thing we need to do is make an appropriate directory. I'm going to call it Hello World App. We'll head into that directory with cd. We want to first of all set up a Ruby application with bundle init, but you may need to install bundler first. This will give us all the packages that we require, including Sinatra. So I'm just going to check my Ruby version that I'm using. I'm currently using Ruby 2.2.1, and I'd like to use a slightly newer variant. So I'm going to switch to my current favorite, which is 2.3.1. Okay. Remember that I said we're going to bundle init. This will create us a gem file. And inside the gem file, we're going to go and add the Sinatra gem. You can see that the gem file is generated with a few pieces of default content. We're not going to need to reference the frozen string literal command, and we also don't want Rails in this case, but it's just demonstrating us how we can include gems. So let's change Rails here to Sinatra. We can, if we want, bring in additional gems. If you wanted to test this, for example, you could bring in RSpec. But we're not going to test drive this specific part of the application. Okay, let's bundle install those gems. So we can see here that it's using Sinatra. These may be green for you if you haven't used Sinatra before. I already have these gems installed to my system, which is why they're in black. Let's create a server file now using touch. I'm just going to call my server file server.rb. And inside it, we're going to create a single simple post route to the index that prints out the request body that we're going to receive from Amazon. This is so we can have a little look at what Amazon's going to send us and dive into it a little bit more deeply. So here I am in server.rb right now. I'm going to require in Sinatra. And I'm going to create a simple post route that just prints out the request. Now, the request comes in with this body method on it, and this will return to us a string IO object, so we'll need to read that in order to print it out to the command line. The next thing we need to do is open this Sinatra application to the internet using ngrok. So let's first of all download the appropriate ngrok package for the operating system from the ngrok downloads page. So here I am at ngrok.com. If I head to the download page, I'm going to be using the macOS 10 64-bit version, and that's going to download. I'll unzip it, And I'm going to transfer this across to my project, which I'm currently using. I'm going to rename this file just to be called ngrok so that I can easily access it. Again, I'll leave it to the watcher if you want to install ngrok more widely across your system. So I'm going to start ngrok using a fairly simple command that ngrok gives us on the command line. I'm going to open it. It's in my current directory. I can see it right here. And I'll start it using the ngrok command. I'm going to supply to it HTTP and give it the port that I know that my Sinatra server is going to be operating on. When I do this, I'm presented with an ngrok information screen that tells me information about my current session. You'll see that I'm using the latest version of ngrok, and although it believes that I'm in the United States, this isn't going to cause me any problems right now. What I want to do is copy the HTTPS forwarding portal as I'm going to push this into my Alexa skills so it knows where to send any requests. So I'm going to copy that. And in a second terminal, I'm going to start my server. Again, my server is called server.rb, so I'll start it simply with ruby server.rb. And we now see that Webrick is listening and Sinatra is ready to take any requests. So part 3 is linking our local server, which is ready to go here, with the skill that we set up on Amazon. And we're going to use ngrok and this tunnel endpoint that we copy-pasted before to do that. So when Amazon invokes an intent, it will send a post request to a specified endpoint. If we go to configuration in our Amazon skill, which we just entered our intents and utterances in, we're going to set up the endpoint here. We're not going to use AWS Lambda, as at current this doesn't support Ruby. Instead, we're going to provide our own HTTPS endpoint. Currently, I'm closer to Europe rather than North America, although my endpoint is in North America, so 6 of one, half a dozen of another there. I'll paste in the endpoint that ngrok has provided me. Note again that it must be an HTTPS endpoint. We can't just use HTTP. And we're not going to need any form of account linking or permissions granted for this application. So a little note on this HTTPS thing. Amazon Alexa only sends requests to secure endpoints. That is, ones that are secured using an SSL certificate, which is what the S means in HTTPS. It means secure. Since we used ngrok to set up our HTTPS endpoint, we can use ngrok's wildcard certificate instead of providing our own. So when we go to the next page, you'll see that it'll ask us for a certificate which certifies that this is a secure endpoint. Since we're using ngroks, we are a subdomain of a domain that has a wildcard certificate from a certificate authority. And let's hit next. So we should now have hooked our Amazon Alexa skill up to our local server. Let's try sending a request from the service simulator, which is further down this page, across to our Alexa skill, across to our Sinatra application, and check that that is printed out. So this is the service simulator. It allows us to test out utterances. Of course, we could also do this on an Alexa-enabled device that's attached to my account, but we'll do it here to start with. Once you've written an utterance into the service simulator, you can send test requests to the application endpoint that you defined. And you can see your application's response to each request that you send. So let's use the service simulator to test that the say hello world utterances causes Amazon to send an intent request to our local application, And we're going to observe the request body printed to the command line and check that it matches the JSON request that was sent in the service simulator. Kind of a sanity check, if you will. So we expected the response to be invalid. After all, we're not actually responding with anything from our application. And this is what Alexa currently reckons was sent across to your application. So let's go check that out. And as expected, we have got this rather messy JSON hash. And we can see from a quick visual inspect that it does appear to match what Amazon believes that it was sent. We can check first of all this quick session ID element here should start with E60DCC, and we can see here we have a session ID E60DCC. So our sanity check is working. We're able to send requests through to our local application. Great. Okay, on to our last step. Now we've built an Alexa development skill. It's all here. We've built our local development server with an endpoint which is tunneled through ngrok. And we can make requests from Amazon to our local development server via that endpoint. So our final step is to construct a response from our endpoint such that Amazon can interpret the response to make Alexa say "Hello World" to the user. Amazon sends and receives JSON responses in a particular format. So let's set that up here. We're going to interact directly with JSON. There are frameworks which will do this for us, and in later modules we'll be using those frameworks. For the first initial modules though, let's interact directly with the JSON so we've got a really clear idea of what's going on. So we're going to require JSON in our Sinatra server file, and we're going to replace the body of our Sinatra post route with the smallest possible response. And you can see the smallest possible response both in the corresponding blog post for this video and in the Alexa Skills Kit response body documentation. So this is a JSON object that's going to be sent back. So we'll create a hash and we'll call to.json on the end of it. We have to send back a version. We're just going to use 1.0 here. This is a required string and it allows us to version our responses. We need to send back a response object, which again is going to be a JSON object. The response tells Alexa how to respond. This thing will tell Alexa how to respond, including speech, cards, prompts for more information, some aspects of account linking when we get to that. For now, all we want to do is provide Alexa one key in the response area, and that is the output speech key. Again, this is a JSON object, and it tells Alexa what to say. The output speech object requires two keys. The first one is a type, and we're just going to give our output speech response to Alexa in plain text. This tells Alexa to use plain text speech, where Alexa will try and guess pronunciation. You can also, instead of this, you can use SSML, which is speech synthesis markup language, where you can specify pronunciation very tightly if you have some unusual or unrecognizable words to pronounce. We're going to use plain text for now. And the last thing, of course, is the response that we actually want Alexa to speak. That's the text here. So this is, again, a required string, and this tells Alexa exactly what to respond with. Well, 10 guesses for what we're going to write here. We're going to use the words "Hello World." Okay, let's save that up. We'll restart our server. We don't need to restart ngrok each time we make changes. Ngrok is just going to keep tunneling any requests to this endpoint directly to our local host at 4567. We just need to restart our server to reload the code. Alternatively, you could use some sort of guard system that will restart the server for you, or a more sophisticated launching gem such as Shotgun. So now we've built this JSON response, we've restarted the server, let's test out the new response in the service simulator. Let's ask Alexa to say "Hello World" again. And you see we now receive a valid response with exactly what we wrote. It's added on a couple of additional things, this speechlet response entity and an empty sessions attribute bracket, but we'll talk about those in subsequent modules. For now, let's see if we can listen to the response coming back. So we've said Alexa to say "Hello World."
Hello World.
and Alexa has responded with it. So if you would like to try your new Hello World skill out live, you can ask Hello World to say Hello World on any Alexa-enabled device registered to your developer account. All the code available for this video is on GitHub, so please feel free to download it and have a play around. Thank you for joining us for Module 1 of the Ruby Alexa course, and I'll see you next time.